Good morning, everyone. So today in our fluid and particle mechanics class, we will still continue discussing about how to quantify friction, as a form of energy loss when some fluid is flowing into the pipeline. So maybe uh, just to refresh you how to calculate the friction loss is basically you need to define or you need to calculate the friction factor. Yeah, the friction factor is basically the ratio between the friction stress divided by half times density times square of the velocity. But since to calculate the shear stress at the wall is difficult throughout the experiment, so basically to calculate friction factor, we will using some other correlation, based on the types or types or flow regime. So for the laminar flow, the friction factor will be inversely proportional to the Reynolds number. So if you are using friction factor of the fanning, it's just 16 divided by Reynolds number. But if you are using Moody, multiply by 4. But just remember, if you already get the value of friction factor, then to calculate the friction loss, just remember again, the unit of small EF should be in joule per kilogram for the standard unit. So it's energy per mass. So after you get the friction factor, if you are using fanning, you have to multiply by 4 times L per D times half times square of velocity. But if you are using Moody fanning factor, you don't need to use 4 again to calculate the EF. That's just basic principle. For the laminar flow, you just use this equation. But for the turbulent flow, basically the friction factor is not only influenced by the Reynolds number, but it will be influenced also by the pipe roughness inside the pipeline. So different materials of pipe and how the pipe is, how is the condition of the pipe will influence the value of epsilon. Epsilon is the roughness. The roughness is basically showing you the, this one, the unbalance of the surface, the unsmoothness of the surface. So you can use the some correlation equation to calculate the fanning friction factor or the Moody friction factor, but you can also use the fanning diagram. So the fanning diagram will correlate the fanning friction factor to the Reynolds number. In our last discussion, we have seen the profile of the graph for the laminar flow and also for the turbulent flow. Okay, so maybe to further, for you to understand better about how to calculate the friction factor, so let's do the exercise. You have this exercise. Actually, in the slide we have the solution, but the solution is, I think, is incorrect. So later we will check. This is the data. So from the data, you can see that the system is the oil transportation. Oil at the flow rate of 200 liter per minute is transported from tank A to tank B through a straight pipe with the length of 200 meters. And the diameter, you can see from the problems, the size of the diameter is not directly given. So it's in the data of the nominal size. Is 3 inches nominal size with schedule 40. And then the oil properties, the density is 850 kilogram per cubic meters, and the viscosity is 45 centipoise. Okay, you can see from the problem, and I think you have learned also from our previous exam, that the units of each parameter is not in the same standard unit. So if you want to use, or if you want to calculate using standard unit, you have to convert them first, all into the standard unit. Make sure to calculate in the same, not in the same unit, but in the same types of the unit. So if you're using standard unit, so you have to convert all the value of the parameters into the standard unit. Okay, the tank A is closed and tank B is open to the atmosphere. Yeah, and then the level of oil in the tank A is the same as the oil in the tank B. Okay, oil fills only part of the tank volumes, and what will be the pressure of the of the oil at the tank A. Yeah, so this is the tank A, this is the tank B. Tank A is closed, so you ask what is the pressure at point 1. Tank B is open, so P2 will be, what will be the value if it's open to the atmosphere? Hello? If the surface of oil in tank B is open to the atmosphere, so the pressure at point 2 will be, what will be the value?
1 atm.
1 atm, okay. If you are writing in standard unit, what will be the pressure?
101325.
101325, okay. So 1.0, just a sec. 1.01 times 10 to the power of 5 Pascal. Okay, and then pipe diameters is already in, pipe length is already in standard unit. And then the volumetric flow rate is 200, yeah, 200 liter per minute, yeah. So this one is 200 liter per minute will be equals how much in SI unit, in standard unit? Please do the calculation, yeah. Just don't stare at the screen, do nothing. Yeah, you will have problems later during your exam if you are not practicing enough. Yes, so start, please use your pen, paper, and also you can use a calculator to help your calculation. So if you are calculating in standard unit, so you have to convert it into cubic meter per second. So how much is 200 liter per minute into cubic meter per second? You please do the calculation. I will not doing the calculation. I will wait until somebody speak up.
Is it 0.003, sir?
0.003.
0.033.
So 3 times 10 to the power of
-3.
minus 3.
Yes.
Okay. For other student, please do the calculation and recheck whether the number is correct. Okay, the volumetric flow rate is already known, and then the density, yeah, the density is 850. It's already in standard unit. So the viscosity, I think the number is different, yeah. Use this number. So the viscosity is 45 centipoise. I think please convert it into the standard unit. What is the standard unit of the viscosity? Anyone still remember?
Is it Pascal second?
Yes, Pascal second. So please convert it into Pascal second. So should be,
Is it 0.04545?
yeah, 0.045. So 4.5 times 10 to the power of minus 2, right? Okay, now you convert the viscosity and then you convert all the other parameters. Okay, now about, you need to calculate, you want to calculate EF, right? Before you can calculate EF, you need to calculate the friction factor. Okay, before you can find the value of the friction factor, you need to know the value of Reynolds number. Reynolds number is the function of density, diameters, velocity, and viscosity. Yeah, density, you already have the number. Viscosity, you already have the number. Now, the diameters, how to get the diameters? Please pay attention that the size is 3 inches, schedule 40. So please find what will be the internal diameter if you have 3 inches, schedule 40. What will be the value in meters? Because you calculate again in standard unit. You can open your textbook or open the, if you have in the slide, you can use the value in the slide, but make sure you get the value of internal diameters, the inside diameters. What is the value? In meters. Don't forget to calculate in meters.
Is it 0.07, sir? 0.077.
Okay, so 7.7 times 10 to the power of minus pangkatnya minus berapa? 2 or 3?
Yeah, yes, sir. -2.
Yeah. Okay, so you already have the value of the diameters. Yeah, to calculate Reynolds number. Then how to calculate velocity? You have the value of the diameters, and then you have the value of volumetric flow rate. So you can calculate divided by A, right? A is the cross-sectional area. So this is Q divided by this one. Please do the calculation. How much is the velocity? Yeah, 3 times 10 to the power of minus 3 cubic meters per second. Yeah, divided by the cross-sectional area. For the cross-sectional area is you are using the diameter is 7.7 times 10 to the power of minus 2. How much? The unit should be in meter per second.
Is it 0.64, sir?
How much?
644.
So 644 times 10 to the power of minus 1 meter per second. Okay, now you already have the value of the density, 850. The diameter is 7.7 times 10 to the power of minus 2. The velocity is 6.44 times 10 to the power of minus 1 divided by the mu. Mu is 4.5 times 10 to the power of minus 2. So you can calculate how much is the Reynolds number. Please do the calculation. How much is the Reynolds number? Have you got the value already? Density times diameters times velocity divided by the velocity. Divided by the viscosity. How much? Why it takes quite long to calculate?
Sir, is it 36.5? I might be wrong.
36.5. Very small.
Okay.
No. The number is quite small. I don't know about the others. Do you have the numbers, other student?
I got 936.
936.
Yeah, I got 9,366, sir. I don't know.
9,360. How come it's so different? Please also include the order of the decimal, right? In the calculation.
I got 936.
936. Okay, the others, I just used the most used number. Just be careful when you're doing your calculation. The density is 850, yeah, in kilogram per cubic meters, and then the diameter is 7.7 times 10 to the power of minus 2. The velocity is 6.44 times 10 to the power of the minus 1, and then divided by the mu. Mu is how much? 4.5 times 10 to the power of minus 2. All is already in standard unit. Any other?
I got 936, sir.
936. Okay, so it should be around that much. Yeah. So if you have 936 for the Reynolds number, the flow regime will be in laminar, right? Yeah, it's very, very small. Unless this 9,360, it should be in turbulent already. But if you have 936 for the Reynolds number, so it will be in laminar flow. So for the laminar flow, I'll write here, friction factor will be 16 divided by RE. Berapa? Please calculate. 16 divided by 936.
Zero 0.017, sir.
So 1.7 times 10 to the power of minus
2.
minus 2. Okay. Okay. So now please calculate EF. Yeah, after you got friction factor, then you can calculate EF, right? The formula is 4 times length per diameters times friction factors times half times square of the velocity. Yeah. Friction factor is 1.7 times 10 to the power of minus 2, and the velocity is 6.44 times 10 to the power of minus 1. L, you have the number. L is 200 meters, and then diameters is 7.7 times 10 to the power of minus 2. Why I like to use how to say in the order of tens to the power of something, because it minimizes the wrong calculation. Yeah. So if you write like 0.00 something or 0.000 something, when you input to the calculator, the chance of mistakenly put the zero, the numbers, the total of the zero sometimes is wrong. So I prefer you are using the order of the 10. But it's up to you. If just be careful, just pay attention when you input the numbers in the calculator. Okay, how much is the EF? Don't forget the velocity is square of the velocity. And since you are using 16 divided by Reynolds number, when you calculate EF, you still have to multiply by 4. But if you are already using 64 divided by Reynolds number, so you please pay attention, do not use 4 again in EF calculation. How much? Berapa EF-nya? Anyone get the answer already?
Sir, I got 36.63.
36.63.
63.
Okay. What will be the unit? Do you still remember? What is the unit
Here,
of
sir.
EF? What will be the unit of this friction loss? Hello, Aurel, you still there?
Yes, sir. Is it something like meters square per second? I'm not sure, sir.
Yeah, this one that you have to pay attention when you do the calculation. Please not only understand or memorize the formula, but you need to pay attention what will be the unit of the each parameters. Yeah. So since you are using all in the standard unit, the unit of EF will be joule per kilogram. EF is energy, right? But this one is not only energy, but this is the specific energy. Energy per mass. So if you are using standard unit, energy is joule, mass is kilogram. So it should be in joule per kilogram. Okay, anyone got the same value, 36.63? Atau ada yang beda?
I got the same answer, sir.
Okay, so I got confirmation about this number. Okay, now you find EF already. Yeah, this is not the final answer, because what has been asked is the pressure at the tank 1. So this one, P1, this one. So in order to get the value of pressure at point 1, you have to do what? After you get the EF, what do you do next?
Input it to the Bernoulli equation.
Okay, you do the Bernoulli equation. Bernoulli equation require 2 points, right? So basically, you do the energy balance between 2 points. The total of the energy between these 2 points should be the same. So which 2 points that you choose? Between what point and what point? Which point and which point? For the Bernoulli?
The surface of the liquid on the 2 tanks, I guess.
Yeah, you can choose point 1 and point 2. Point 1 is the surface at tank, the first tank, and point 2 at the surface of second tank, tank A and tank B. And you have the information here is the tank A is closed, the tank B is open to the atmosphere, and then the level of oil in tank B is the same as in tank B. So from this information, you can say that Z1 will equals Z2. Yeah, because the level is the same. And then how about the velocity? You have potential, right? You have kinetic, you have pressure. And then you have energy loss in Bernoulli now. Yeah. Then from the potential side, yeah, from the potential energy, you have no difference in height. So there will be no change of the potential energy. And how about the velocity? Between point A and between point 1 and point 2.
Well, we can assume it's negligible.
Why you can say it's negligible or zero?
Because we just assume that the tanks are big in diameter, large in diameter.
Okay, and then the other one is we do the Bernoulli equation when the condition is already steady, right? So you can understand or you can imagine the process. So first you have oil from tank A, yeah, from the first tank you have oil, and then this oil will flow through tank B to the second tank through the straight pipeline. Yeah, during the flow in the straight pipeline, yeah, the oil is moving, right? The oil is moving with the velocity that you have calculated, 6.44 something, yeah. The oil is moving with a certain velocity, and during the flow, the oil will release some energy lost to the environment in terms of heat, right? Then you calculate the value, 36.63 joule per kilograms. Yeah, so during the flow, there will be some energy loss, yeah, and then it will be filling the tank B until certain position, and then it stops. It's steady. At the steady condition, from the information, the level of both tank is the same. Yeah, in the steady conditions means there will be no change in the liquid levels. It's already steady. Then the velocity will be both are zero. So the velocity at point 1 at the surface, first tank, and at point 2 also at the surface, the second tank, both are zero. The velocity that you have calculated, yeah, 6.44, is only the velocity during the travel of the oil in the straight pipeline. Well, we need to know the value of this velocity in the straight pipeline to calculate EF. Okay. I hope you understand the explanation, right? So in terms of velocity, when you compare point 1 and point 2, they don't have any value of the velocity. So you can use 0. So you can put it into the, let me clear some space here. Yeah. You can write down the Bernoulli equation. P1 divided by, so I'm using head, yeah. Sorry, not using head. You sorry. You should use the specific energy. Sorry for my mistake. Yeah, in terms of specific energy, because you already calculate the EF minus EF, yeah, equals yeah. So if you are comparing between point 1 and point 2, the formulation of the Bernoulli equation should be like this in terms of specific energy. So for the pressure is pressure divided by density. For the potential is gravitational acceleration times height. Yeah. For the kinetic is half times square of the velocity. Okay, from the previous information, since Z1 equals Z2, so it will cancel out each other. Okay, U1 and U2 is 0. Yeah, it should be 0. Okay, P2 is open to the atmosphere, so the value is this one in Pascal. Yeah, you are using standard unit. Then EF, you have the value 36.63. You have the value of the density 850. Yeah. Then you can calculate the value of P1. Please calculate. Do the calculation. If P2 is atmospheric, yeah, 1.01 times 10 to the power of 5 Pascal, then you should be able to calculate the P1. Don't forget to incorporate EF. EF in the minus form is 36.63. Okay, please do the calculation.
Is it 132,125.5, sir?
Okay. Can you use like this form 10 to the power
Okay.
of something Pascal?
1.32 times
1.32
1032
uh-huh.
times 10 to the power 5.
5. Okay. Thank you. Okay. How about the other student? Can you do the calculation to confirm the calculation is correct?
I got the same number as Mazaya, sir.
Okay. Hopefully the other student will have the same value. Okay. Hopefully after doing these steps of calculation, you can understand how to do the how to generate, how to understand the phenomena from the soal, from the exercise, how to understand the phenomena, how to describe the phenomena into the figures, because it will help you. These figures, if you are doing the exam later, this figure won't be, maybe it won't be given to you. So you need to draw the diagram, the figures of the phenomena by yourself. And then from these figures, it will help you to understand the problems. It will help you what you need to calculate first. In this one, you need to identify and then calculate the friction loss, EF. EF in joule per kilogram in specific energy. Actually, you can use other units, but maybe to calculate in other units is not as simple in standard unit. Maybe we already used to calculate in standard unit, is okay. Even though if you were asked to have the value in other unit, then you can just convert, right? You convert into the unit, the unit that you need to provide. But you need to understand what kind of the parameter that you have to calculate first. In this one, you need to calculate EF, but you need to do the calculation of friction factor first, and then before doing the friction factor, you need to calculate the Reynolds number. In this problem, we find out that the Reynolds number is very small, so it is in the range of laminar, so you can use directly the formula. But if it falls into the turbulent, then you need to see from the diagram. You can see from the diagram. You can check, the pipe roughness is provided. So in this case, since the flow pattern or flow regime is laminar, we do not use this value, right? But if the Reynolds number is high, in turbulent, then you might need to use this value. Then how to get the friction factor? Then you can use the graph. Then the following procedure should be the same. After get the friction factor, you calculate EF. After you get the EF value, you calculate P1 by using the Bernoulli. Just remember, Bernoulli is basically only comparing 2 points. You compare 2 points. These 2 points should have same total energy. But now the component of the energy is not only pressure, kinetic, and potential, but you also have EF. You can put it in the left one, in the left side, so the sign will be minus, or you can put it on the right side. The sign will be positive, the plus. It's up to you. But just remember, if you are calculating EF in the unit of specific energy, make sure each component should be in the unit of specific energy. Then you put EF. If you put it in the left, then minus. Okay, so basically you're comparing 2 points in Bernoulli. And you have to understand again, from the diagram, from the figure, what will be the condition of each point, like this one. So the surface is the same. So the potential energy, the differences is 0. So both surfaces are already in the steady condition, right, in the Bernoulli. So the velocity is also can be assumed to be 0. Okay, any question about this exercise? Again, I remind you to open the textbook or maybe open the prosol, open some other exercise, you redo the calculation. Yeah, it helps you to understand better about how to understand the phenomena, understand the assumption. Yeah, it's also important. And then also it will help you to practice doing the calculation in the limited time. Okay, any question? Okay, maybe before I, you can see the calculation is not correct. Okay, maybe I will explain a bit about friction, but I think I have explained to you early in the previous class that friction is not only comes from the friction between, friction loss is not only comes from the friction between the fluid and the pipe, yeah, but also it comes from the installment of the fitting. Yeah, the fitting is basically the pipe accessories. You will have a lot of kind of fitting. Yeah, it's like this one. Yeah, it's called a T because the size is the T. Yeah, so to connect 3 different pipe, yeah, to make a branch of the pipe, then you need to use T like this, or maybe you need to use elbow. You need to use Y. Yeah, this one, because the shape is like Y alphabet. Yeah, it's also to branch the pipeline. And you need also to use maybe sudden contraction, maybe a diffuser, maybe a sudden enlargement, and so on. So basically, it's to connect pipe to make a pipeline system. Yeah. Or maybe you might need to install a strainer. Strainer is, do you know? Do you know the strainer? What is the function of strainer? Anyone want to guess?
It's saringan, right, sir?
Yes, it's a filter. Yeah. So basically, if you have a suspended solid, yeah, in your fluid, yeah, if you suspect or if the fluid, whether it's in the gas form or in the liquid form, contain solid, the particle of the solid that is suspended in the fluid, and you don't want this solid to be involved in the further system, maybe do not involve, it will damage the pump or it will damage the reactor, yeah. So you don't want this solid to be carried over into the reactor or the pump. Then in certain pathways, in the certain position, you can install strainer, the filter. Yeah, this is the filter. So basically, when it flows, the solid particle will be retained in this filter. Then it will flows into the next pipeline system without the solid. And also, oops, how to stop it?
Welcome to the hardenengineer.com.
Okay, just a minute.
I'm Varun Patel.
Yeah, I think I won't play it for you, but beside fitting strainer, we also have valve. So in fluid or in the pipeline system, we have several types of valve with different function. Yeah, some valve can be function to adjust the flow rate. Yeah, so you can manipulate the flow rate. Yeah, you can adjust from smaller flow rate into bigger flow rate, vice versa, or you can adjust whether it's flow or no flow, like open and close. Yeah, or in some function, valve can be used to avoid what we call back pressure. Yeah, so like this one, the check valve, I have put several videos in the EduNext to explain, to show the different function of valves. You can watch it one by one later at your convenient time. Yeah, this one is check valve. Is also important when you do not want any backflow. Like this one, if the fluid is flowing from left to right, then the fluid can flow, right? But if for some reasons the pressure at the right is higher than the pressure at the left, the fluid will flow back, right? It will. That's what we call backflow. So if you have backflow and you do not want it to be happen, then you install check valve. It will close if the flows are coming from the right to the left direction. Okay. Actually, in this video, you can see as well some differences in the valve, but I'll show you in the next class. Okay, any question until this point? Okay, I'll stop first.